Hi, I'm Dick Seitz. Welcome to the Understanding Software Dynamics video series. Today's topic is the KUtrace analysis of Hello World. This is the Hello World program in black, and I added two optional trace entries. This one adds the word hello at the very first line of execution. This adds /hello at the very last line before the return. After post-processing the trace, we get something like this, which you may have seen in the first video. I'm going to switch now to the full trace live HTML. So this full trace is about 3.5 seconds, where hello is in the middle. You can use the mouse wheel rotating to zoom in and out. One of the things you see here is an overlay of CPU frequency. The red areas are running at a fifth of normal speed. The yellow areas at partial speed, and the green areas, which we don't have here, at full speed. That's useful if you're running, if you have some performance problem, and the thing you need to know first is, oh, the CPUs are all running at a fifth of normal speed, no wonder it's slow. And then you don't have to waste your time looking for other problems. I'll turn this off, and then we'll zoom in on hello. And you see here some timer interrupts on all four CPUs, more timer interrupts 4 milliseconds later, more timer interrupts, more timer interrupts. If we look at just hello and zoom in a little bit more on it, down here it starts with an Ethernet interrupt bringing in a packet that says /hello carriage return. If we click up here on the users, we can give the names of all the user processes. So here's the SSH daemon, here's actually a kernel worker, here's the bash command line interpreter. It spawns with clone another copy of itself, bash. It does an exevc to load and branch to the Hello World program. That program starts out with a bunch of page faults, and then down here is the beginning and end of hello itself. If we zoom in on that part a little bit, shift over, I've added an overlay of instructions per cycle, which show over here very low instructions per cycle. These are little speedometers with, over on the far right, the legend. And then it gets a little faster and faster and faster as there's this whole burst of page faults. So what's happening here is you can see the page fault routine loading the L1 caches with its working set. Meanwhile, the user code working set is, of course, getting overwritten. And so the user code in between a burst like this can get slower and slower. If we move in a little bit and look at this system call, which is an fstat, and zoom way in on it, you can just barely see these little white diagonal lines at each edge. These are showing the approximate KUtrace overhead of recording that event, that change from kernel mode to user mode. I think it's important when you're building an observation tool to have some way of the tool showing you approximately how much overhead it's creating, because if you have a whole bunch of use of the tool right close together, it may end up distorting the thing you're measuring. And this way you can see it. If we go look at the end of Hello World, what we can see is the beginning of Hello World, a bunch of page faults, a few system calls, and then finally the write of 12 bytes, Hello World carriage return. That write wakes up this kernel thread, kernel worker thread, which wakes up the SSH daemon, which does a write to a network socket of 52 bytes. So this 12 bytes is turned into 52 bytes. The 40 byte difference is 20 bytes of IP header and 20 bytes of TCP header. So you get to see all those kinds of details as you're looking at the kernel user trace. If we go back to the beginning and start with this Ethernet interrupt and go over here to the right, we get to see down here at the bottom 2.43 milliseconds total elapsed time. But with KUtrace, you get to see exactly where every nanosecond of that elapsed time went, going through the critical path to get to the final write. So you can see for any kind of transaction exactly what the delay path and what's on it and why a particular one is slow. And you can see how a slow transaction differs from a normal speed transaction by the extra things in the timeline. So if we switch back, I just want to thank you again for listening. This is part of the Understanding Software Dynamics video series. Take care.